Hi, welcome back to the Shuko Math Practice Lab Algebra 2 lecture series. And we are still in the chapter 2. And in this video for the lesson 2.11, we're going to talk about a special function. We talk about another special function. We're going to take a look at what is the step function and what is the graph of the step function. So for the step function, typical, the most of the teacher were covered in the honor algebra 2. If for the regular algebra 2, probably will not be covered. So if you want to skip, maybe, maybe okay, but always check to see, whether your teacher will cover this or not, all right? So I'm going to go to the whiteboard first to take a look at what is the step functions and what is the function looks like associated with it. And then we're going to our worksheets to take a look at how do we graph it and how do we do it. Okay, so the first thing we're going to talk about is we call this the greatest integer function here, all right? So how do we define like the greatest integer function? So we said f of x is equal to, so this is the notation. It's kind of like a bracket, but with extra lines there. And so here, okay. So that's what we call is the greatest integer functions. What that means? That means whatever the value, whatever the function value, right? So let's see here. Let's say that means the function value is always going to be integer. Okay, so for examples here, and so like in here, like if I say f of 3, that means here, this is 3, right? So if it itself is 3, yeah, then it's already come out with 3. How about if I have like -2 in this function, and because this is integer, so it will be -2. So whenever is the whole number, then it come out as integers, all right? Okay, so now let's take a look at what is the greatest integers means here. So how about if I have a number 1.95? Okay, so now I have a decimals, right? So it's 1.95. So for these numbers here, what is this function mean? That means, whenever you come out, has to be an integer. So this integer has to be less than 1.95, and it's the greatest one less than, because you can have 0 less than it, -1 less than it, but I wanted the greatest one. So what is the biggest number is less than the 1.95? It's 1, right? Remember, it's always come out with the integer. So like in here, if I have a 1.0002, okay, so this is 1.0002. So what is the integers here? So where is still 1. So typical, is very easy if you do like a number lines here. So it's always will be the numbers on your left-hand side because it's less than, right? Okay, so let's try to take a look at other examples here. So if I have 2.15, okay, so 2.15, you say, hey, where's 2.15? 2.15 is something here, right? So after the function is always be the numbers right and left to it. So what is the number here? Is 2. All right. Okay, so let's try to do a few more, and then you will get a better at it. 0.333. Okay, so if I have a 0.333, so where is the 0.333? It's somewhere here, right? So it's always right next to it. So what is this number come out here? It's 0. All right, so now let's take a look at the negative ones here. So if I have a negative 1.245, okay, so if it's negative 1.245, so what is the negative 1.245 somewhere here, right? So it's a negative 1.245. So what is this number? It's always to the left, right? So what is here? It's negative 2, right? So here, if I have a negative 3.44, so what is this number here? Negative 3.44 is something here. So it's always less than that, right? So what is this here? Negative 4. Okay, so now let's take a look. If you do give me the f of x just by itself, right? Okay, so then what is the graph looks like? So let's do this. So maybe, okay, let's do a better graph, you know, okay, so here, straighter. Okay, so straight, okay, and here, okay. All right, so now I have, let's do here, this is 1, 2, 3, 4, and this is negative 1, negative 2, negative 3, and this is 1, 2, 3, 4, and this is negative 1, negative 2, negative 3. Okay, so now let's see here, right? So we say when x equal to 0, right? So when x equal to 0 will be 0 itself, right? And when x equal to 1, as we did, 1 going to be like this. X equal to 2, what here? So function will be 2. X equal to 3, what is going to be here? What is here, right? So now also from the number lines, we know, you know, for everything, right? So here, just look here, right? So for everything, you know, on the left-hand side of the 1, what is they going to become to like for everything, like from here to here, doesn't matter every value. So what is this function come out with? Is come out with what? Zeros, right? So that's why I can graph this function. This is be all those, so this will be the function values always be 0. Then here is the circles, right? Because of when it is equal to 1, will jump. So the same ways here, any numbers in here between 1 and 2, the function value will be always the left. So it will go like this. Right now, when x equal to 2, it's a jump to 2. So here, this one put the 2 is a little too high. Okay, so let's find, so this 2 here, right? So the same way, anything between here, right? So I'm going to have all these ways here, right? So that's why you can see, right? So this is a continue. So that's why you can see this is go boom, 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 like stairs, right? Okay, so now let's take a look at the left-hand side. The left-hand side is here, right? Where x equal to negative 1, so it's a negative 1. When x equal to negative 2 is negative 2. When x equal to negative 3 is negative 3. Okay, take a look here. For everything in between here, you know, in between the here, right? So let's try to put from the 0 to negative 1. So what is going to jump to the negative 1? That means for everything is in here, what are they going to jump to? They're going to jump to negative 1, correct? So now that's why I know this will be my values, right? Because everything, these yellow things here, like a negative 0.05, negative 0.75, will jump to negative 1. So the same things here, right? So if you take a look here, right? So everything between negative 1 and 2. Okay, negative 1 and 2, they're going to jump to what? Here, going to jump to the negative 2s, right? So that's why the end is like this. And this one is like this. So see, that's what we call this is the step functions, kind of you walking the stairs, right? The steps, you go to there. So the key things is pretty, I think it's pretty easy to kind of graph. You just graph the whole number first, right? Then you see where they're going to make a jump, right? And then because it's the greatest integer, so it's always less than, so it's go to the left. So far, so good? Okay, so now let's take a look at our examples, right? So the worksheets. Okay, so I'm going to stop the sharing here. I am going to go to our worksheets. Oh, so what happened? So it's still, that's okay, so here I will say share. Okay, good. So this is our worksheets. And now I'm going to make, I guess this is a little bit bigger so I can graph, right? So here, so I can graph easily so you guys can see better. Okay. All right, so now, ooh, I don't want to overdo it, right? So here, okay, get a little, okay. Okay, so now let's take a look here. The first one's here, right? Oops. So I want to get this one. Okay, doesn't matter. Okay, so this one's here. Okay, let's take a look. The first one's here, right? All right, so this is x plus 1, right? Okay, so now let's choose a few points first so we can mark, so we can know how to mark our jumping point. Okay, so let's start here. So when x equal to 0, what is my point? 0 plus 1 is 1, right? If it itself is always integer. So, okay, so now x equal to 1. What is x equal to 1? 1 plus 1 equal to what? 2. Okay, x equal to 2. 2 plus 1 equal to what? 3, right? And then x equal to 3. 3 plus 1 equal to what? 4. X equal to 4 is equal to 5. Okay, so let's plot the right one. Okay, so the right one's here. Let me use the red. 0, right? When x equal to 0, I have 1s here. So this is a solid, correct? Okay, so this is a solid. So I know it's going to jump here. X equal to 1 is 2. X1, 2. So this is a solid. So let's another jump. X equal to 2 is equal to 3. So this is another jump. X equal to 3, 1, 2, 3. Oh, 2 is here. 3 is 4, right? Then 4 is 5, okay? So those are my right-hand side points, right? Okay, so now in here, right? So I know it's going to jump right in here. So that's why my graph is like, so here's a circle, here's a circle, here's a circle, and here's a circle, right? So that is how my steps go when x is greater than, okay, 0 here. So now let's take a look at x equal to negative 1 here. When x equal to negative 1, what happened to my y value? Negative 1 plus 1 is what? It's 0. Then x equal to negative 2. What is my y value? Negative 2 plus 1 is negative 1. So it's come out with negative 1. X equal to negative 3. What is my y value? Negative 3 plus 1 equal to what? Negative 2, right? Okay, let's choose a few more. Negative 4 will go out as negative 3. Then x equal to negative 5, it should go out with what is negative 4, right? Okay, so now let's kind of try to graph my another side. Okay, so x equal to negative 1 equal to 0. So x equal to negative 1 equal to, so here is a solid, right? And then x equal to negative 2 is negative 1. So negative 2 is negative 1. So here's my solid. And then negative 3 is negative 1. Okay, so this one gets disappeared sometime, this software. Okay, and then negative 3 is 1, 2, 3. Negative 3 is negative 2, right? So this will be my other solid one. X to negative 4 is negative 3, so here. So the last point here we have is negative 5 to negative 4, right? So here is, right? So we say it's always fall onto the left. So here, this will be your graph, right? Right, so now, because your right-hand side is always a circle, it's because you fall back to the left-hand side because it's the greatest, so it's lessons, right? Okay, so now let's take a, so you do all these things is the same way. So you see this is the stairs, right? Okay, so now let's take a look at this one. Okay, so the same way. So x equal to 3, right? Okay, so you can say I start with x equal to Okay, let's start with x equal to 0. So when x equal to 0, 0 minus 0 minus 3 is what? You got a negative 3. Okay, and then x equal to 1. What you have for 1, 1 minus 3 is equal to what? Negative 2. Okay, x equal to 2. 2 minus 3 equal to what? Negative 1. X equal to 3. 3 minus 3 equal to what? 0. X equal to 4. What is 4? 4 minus 3 equal to what? Equal to 1. Let's choose one more. X equal to 5. What is here? This is 2, right? Okay, so let's plot my right-hand side one. So, okay, so x equal to 0 is negative 3. 0, negative 3. 1, 2, 3. Right? So here, you got a solid because when they equal, the whole number is a solid, right? 1 is negative 2. 1 is negative 2. So here is the solid. Then 2 is negative 1. So here, this one is solid. And 3 is equal to 0. So this one is solid. 4 is equal to 1, right? So this one, 5 equal to 2, right? So that's it. And then we say the open circle is always to the right. So here, that's why here you got a boom, 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 right? Okay, now let's take a look at the left-hand side. So let's see x equal to negative 1. When x equal to negative 1, so negative 1 minus 3 is what? Negative 4, right? Then x equal to negative 2. What is negative 2? Is negative 2 minus 3 is what? Negative 5. X equal to negative 3. The graph only gives us 3, so negative 3 is negative 6. Okay, so then let's try to graph the one less than 0. So x equal to negative 1 is negative 4. 1, 2, 3, 4. So here, so this is the solid here. Negative 2 is negative 5. So this is another solid dot here. And negative 3, negative 6. So it's another solid dot. And then what happens here? Here, right? So it's the right-hand side, so it's the circles here. So that is what we call this, the step function. So it's really pretty easy, right? So when you try to graph it, so what you try to do here, so you identify the whole numbers first, right? That's why we always, like in here, we always say, okay, you start with like, it's 1, 2, 3, the whole number, because I know the whole number is the solid. And so the same here, you start with the whole number, right? So you choose a few positive x, few negative x, and then you fill it in. So whatever that whole number start and end with the next whole number going to jump, right? So then that's why you put a circle there. So that's why you see this is what we call this the step function. And that's it, right? So it's kind of like a pretty fun function to work with. And then the next video, we're going to talk about another special function. That will be the absolute value function. That one, it's another fun functions here. So like I said, for the greatest integer function, most likely, if you are taking the regular Algebra 2, probably your teacher will not cover. But for the honor, your teacher, I think it definitely should cover the greatest integer functions. Okay. All right. So that's it. And it's so nice to talk to you, and hope you enjoyed the video, and have a good day. And looking forward to talk to you again in our next videos. Okay.